Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the concurrence or the feedback from each one of you regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to go. The agenda behind today's video is to cover the complete questions which have come from the topic of vector calculus as well as integral as well as differential calculus, which has been appeared in year of 2021. And it has been the 11th question of the series of the engineering mathematics. What we are doing in this series, we are consolidating all of the questions which have come in GATE 2021 into the topic wise. So probably around 40 to 45 number of problems is already been taken. So remaining 20 to 25 number of questions are yet to be taken. So the agenda must be very clear to all of us. We are going to take the questions which have appeared in GATE year of 2021 from the topics called calculus. There I would be considering the problem from differential calculus and integral calculus. Once we are done with these topics, we would be moving into the next part of the calculus. There I would be taking one question from the vector calculus. And if the time permits, we would be taking one or two number of questions from numerical methods. Yes. So without getting delayed, let me straight away jump into the problem. Just a minute. Just a minute. Final. Yes. So the first question is coming from the topic called integral calculus from the page number 26. The first question comes from the page number 26. Let me see what the problem indicates exactly. See what this problem indicates. Just a minute. See, the unit normal vector to the surface x square plus of y square plus of z square minus of 48 is equals to 0. At the point 4, is options were given as 2 divided by root 2, comma of 2 divided by root 2, comma of 2 divided by root 2. Similarly, the option B was 1 divided by root 5, comma of 1 divided by root 5, comma of 1 divided by root 5. Similarly, the option C is 1 divided by root 2, comma of 1 divided by root 2, comma of 1 divided by root 2. Similarly, the D option is 1 divided by root 3, comma of 1 divided by root 3, comma of 1 divided by root 3. So for the better understanding, I would be bringing this problem into the working board. So here goes this problem into the working board. Yes, just a minute. Here goes this problem. Let me bring this problem into the working board. This would be the first question of the day. Just a minute. Tell me what would be the best most answer for this given problem. My dear friends, once you'll see this problem carefully, you'll get to know. You had to draw a unit normal over surface x square plus of y square plus of z square minus of 48 is equals to 0, and that too at a point 4, 4. Yes, the four different options were given, and yes, it was a type of MCQ. May I know how will you get the normal over the surface at the point 4, 4. Tell me what would be your approach. My dear friends, whenever you have the equation of the function, which could be 2D in nature, which could be 3D in nature, then easily with the help of the concept of gradient, you would be able to draw the normal over the given surface. Anyways, once you'll see the surface, how the surface is looking like, my dear friends, once you'll see this surface, you'll get to know. It has been a spherical surface. How? The structure of the sphere used to be x square plus of y square plus of z square is equals to of r square if the radius of the sphere has been r, and if it is being centered along origin, which has been 0, 0, 0. Obviously, the structure of this problem or the structure of this surface is exactly matching with the x square plus of y square plus of z square is equals to of r square. So once you'll compare both of them, yes, you'll get to know both have been centered along their origin, and if you'll calculate the value of r, when the minus 48 goes towards right hand side would become 48. 48 has to get compared with the r, so the value of r would be simply equals to of root over of 48. Root over of 48. So if you precisely wants to draw how the curve would look like, let's take this has been your z-axis, let's take this has been your y-axis, and let's take this has been your x-axis. So how the spherical curve would look like? The spherical curve would look like something this. This would be your spherical curve. This would be your spherical curve. Yes, and you wanted to get the normal over the point 4, 4, 4. Obviously, it would be a point over the first octant. So you had to draw the normal over this point. How will you get the normal over this point? Again, as I have said, you had to use the concept of the gradient. What the concept of the gradient states? If you exactly know the function of the surface, with the help of the gradient, easily you would be able to draw the normal over that surface. And what used to be the equation for that? The equation used to be the gradient of the given function, obviously, which is f of x, y, z, and at denominator we would be dividing with its magnitude. Why? Because we are searching for the unit normal. Obviously, once you will take its gradient, it would have its direction as well as its magnitude. So obviously the magnitude has to be snatched out. And for snatching the magnitude, we had to take the mod of the gradient of the function x, y, z towards denominator side. So now you had to get the gradient of the function f, x, y, z. May I know, once you will compare both of them, what would be the worth of f of x, y, z? Obviously, which is precisely equals to of x square plus of y square plus of z square. Yes. You had to take its gradient. How the gradient is being taken place? You had to differentiate partial with respect to the x. So the function which would be left out is simply going to be 2x would get multiplied with the ax cap. Similarly, y square would get partially differentiated with y. The value which would be left out is simply going to be 2y and would get multiplied with the ay cap. And similarly, z square would be partially differentiated with z, which would become 2z, and now it would get multiplied with the az cap. So if I say, if we had to get the gradient of the function x, y, z, may I know what would be the worth over here? Obviously, it's simply going to be 2x ax cap, 2y ay cap, and at end it's going to be 2z az cap. Yes. So at least the numerator part is clearly known to me. Let me do one thing. Let me slide this complete question a bit. Yes. So now what I would be doing over here? The gradient of f of x, y, z has been precisely filled as 2x ax cap plus of 2y ay cap. Here goes 2z az cap, and at denominator you will take its magnitude. What would be the magnitude? You will take the square of the part of the component which is in the direction of x, in the direction of y, in the direction of z. So the factor which becomes over here is going to be 2 square y square, 2 square y square, 2 square z square. The 2 square can be taken common, and once it's coming out from the square root, only 2 would come out. So the factor which would be left out is simply going to be x square plus of y square plus of z square. This 2 is common with all of the components. So the factor which has been left out is simply going to be x ax cap plus y ay cap plus z az cap divided by of x square plus of y square plus of z square. And that calculation has to be made at the point 4, 4, 4, which has been clearly given in this problem. So instead the x, the precisely value has to be fed as a 4, y as 4, z as 4. Yes, start feeding those values. So the numerator would become 4 times of ax cap, 4 times of ay cap, 4 times of az cap, and at denominator you will be having 4 square, which is nothing but the 16. How many times the 16 would come? 3 times the 16 would come. So it would simply be 3 into 16. Once the 16 goes out, only the 4 would be coming out, and once the 4 goes out, definitely this all component would be vanished. So the factor which would be left out is simply going to be ax cap plus of ay cap plus of az cap divided by of root 3. And if you are searching the unit normal over the point 4 comma 4 comma 4 of a spherical structure of x square plus of y square plus of z square minus of 48 is equals to 0, obviously the unit normal has been 1 upon root 3 in the direction of ax cap, 1 upon root 3 in the direction of ay cap, 1 upon root 3 in the direction of az cap. So what would be the best most answer? You yourself would be able to judge. The best most answer would be this. And one more important thing, B cannot be the answer at all. Why? Once you will take its magnitude, the magnitude is not 1. If you will take its magnitude, how the magnitude would be taken? You will take square of this plus of square of this plus of square of this, and end of the day you will be taking its square root. So square of this is going to be 1 upon 5 plus of 1 upon 5 plus of 1 upon 5. Put together it would be 3 upon 5, and once you will take its square root, the value would be root over 3 upon 5. Whether it is normal or not, that I do not know, but it is not a unit form of normal, so obviously the B has been ruled out. B has been ruled out. Not only that, even the C has been ruled out. How? Again, if you will calculate its magnitude, how the magnitude would be calculated? You will take the square of the component towards the direction of x plus of y plus of z. So here it would become 1 upon root over 2 to the power of 2, that's simply 1 upon 2 plus of 1 upon 2 plus of 1 upon 2. That would become 3 upon 2, and once you will take its square root, the worth would be root 3 divided by 2, which is non-unity. Obviously the C is also being ruled out. C is also being ruled out. And similarly, once you will take the reference of option A, 2 root 2 could have been written as root 2. Again, the second component is also root 2, third component is also root 2. Once you will take its magnitude, obviously it has to be root over 2 square plus of root over 2 square plus of root over 2 square. The result what we get is simply going to be root over 6. So I would say, at least in this problem, they were wanting you to calculate the unit normal. The word is unit. What does that mean of it? That means the result whatever will come in form of unit vector. Obviously B is not a unit vector, C is not a unit vector, A is not a unit vector. Even once you will start filtering out, just watching their options, no, A, B, C could have been ruled out. A, B, C could have been ruled out. So may I know, could you understand what exactly I wanted to say? So till this point probably each and everything must be clear to all of us. Till this point probably each and everything must be clear to all of us. So the best most answer is going to be option A. Yes, in the same sequence, let me take the next question, and that question is coming from the page number 51. Page number 51, just a minute. Just a minute, what is happening? 51. Yes. Let me go into the page number 51. Yes. Here goes the next question. Here goes the next question. I need to find the area between the parabola. The two equations of the parabola is clearly given along with this problem, and that's nothing but the y square is equals to 4 times of ax, and x square is equals to 4 times of ay. I need to get the area occupied or area enclosed by both of these parabolas. And once you'll see the character of this problem has been appeared. This problem has been appeared in EAC Electrical year of 2019. EAC Electrical year of 2019. Tell me what would be the best most answer for this given problem. What would be the best most answer for this given problem? My dear friends, to start with, I had to draw y square of 4ax as well as x square is equals to 4 of ay over the same plane, such that I have the fair idea where the common area has been fabricated. So what I would be doing at very beginning, I would be taking a plane. As I have done it over here. So obviously which plane it has been? It has been xy plane. And now you yourself would be able to understand. We had the two number of parabolas. Y square is equals to a 4ax as well as x square is equals to a 4ay. My dear friends, you yourself would be able to understand. If you will keep the value of y as a positive or negative, what I am saying, whether we will be keeping the value of y as positive or negative, the y square would make it positive. That means for all possible values or all possible real values of y, the x would always be positive. What does that mean of it? That means it is going to be right facing parabola. Yes, because the x is always positive. Right facing parabola. Right facing parabola. parabola. Similarly, in the same sequence, if we focus over the second parabola, here what is happening, my dear friends, there could be the two possible real values of x. It could be plus or it could be minus. If you are feeding the value of x as a plus or minus, in both of the case the value of y has been found to be plus. What does that mean of it? The y is already been positive for all possible values of x. That means it's gonna be upper facing parabola. Upper facing parabola. Upper facing parabola. Yes. So you yourself would be able to understand over the same plane I have drawn the two parabolas. The x square is equals to a 4y has been a upper facing parabola. Let me draw with the green color. And similarly, y square is equals to a 4ax has been the right facing parabola. Has been the right facing parabola. Yes. Has been the right facing parabola. And as far as the problem is concerned, they wanted to calculate the what? Area enclosed by both of the parabola. Obviously, that area has been this sort of leaf. This sort of leaf. How you get the area enclosed? How we get the area enclosed? Obviously, with the help of double integration, we can get the area occupied by these two parabolas. My dear friends, you could have used the two different terminologies or technologies. Either you could have taken horizontal differential surface. With the help of horizontal differential surface, you could have figured it out the finite area which is bounded by this two parabolas, or you could have taken the vertical differential area. So at least for solving this problem, I have taken the vertical differential area. So what I am going to do, let me draw this vertical surface area exclusively outside. My dear friends, as I am saying, it's a vertical differential area. What does that mean by the differential area? That means the differential length in the direction of x is infinitely small. I repeat, the differential length in the direction of x is infinitely small, whereas the value of y is finite. If what I am saying, if the length or the variation towards the direction of x is infinitely small, you can say it is a type of a rectangle. And how we get the area of the rectangle? First, we would be taking its height towards upper side as a function of x, and similarly towards lower side as a function of x. We'll subtract them out. So it would become the height of, or we can write y1 of x minus of y2 of x. It would become the height of this rectangular palette. And yes, the area of the rectangular palette used to be the height into of breadth. May I know what would be the breadth of it? Obviously, the breadth has been infinitely small length in the direction of x. So simply it's going to be d of x. So till this point, each and everything must be clear to all of us. I just wanted to deliberate. Many of the students just by heart the formula. When they use to take a vertical strip, they used to by heart, sir, the formula which we use is going to be the integration over the dx first, dy after, and we will take the lower end as well as the upper limit in terms of x, in terms of y. No, you should not by heart those formulas at all. What I am saying, see. Whenever you want to learn something great, whenever you want to learn something great and you really want to do something great in your life, try to understand from its basic. What I am saying, this has been a leaf. How the area of this leaf can be calculated? First, you can take a vertical strip which is infinitely thin into its width. What I would do, I would just slide this vertical strip from this side to this side, and whatever the area is being occupied, I would try to add them up. That would be the first method. The second method could have been, you could have a horizontal strip, and again you will start adding the area which has been occupied by the horizontal strip from the lowermost side to the uppermost side, and once you are done, you would get the area under the curve. So whenever you focus over the vertical strip, which type of formula has to be used, that we can derive over here. What I am saying, just focus over this strip, the area of this strip. May I know which type of structure this strip has been? It has been a rectangular structure. Why I am saying rectangular structure? Although it has been an edge towards upside as well as downside, I used to take this as a rectangular structure because its width has been taken differentially small or differentially 0. If its edge has been taken differential 0, you can take it has been a straight line, you can take this has been a straight line, you can assume this strip as a rectangular structure. You can assume this structure or this strip as a rectangular structure. So if you'll take the area occupied by this rectangular structure, definitely first you have to talk about its height, how the height has to be calculated. First you take the reference from y is equals to 0 axis till this point, and similarly y is equals to 0 axis till this point, and this height has been taken as y of 1, this height has been taken as y of 2. So first you will subtract y of 1 to y of 2, definitely you will be getting the height of this given vertical step. Once you're done with this, definitely now you have to talk about its width. Width has been clearly decided as d of x. Clearly decided as d of x. Agreed what I'm saying? And end of the day, you had to integrate taking the lower to the uppermost value of x. May I know what would be the lower as well as the uppermost value? You had to start from this point and you had to go till this point. You had to take its lower to the upper value. You have to take its lower to the upper value. Yes, till this point probably each and everything must be done to us. See what I have done? To find the intersection point, I have equated both of the equations such that I would be getting the intersection point over this point. So once I have equated both of them, the point of the intersection what we got during calculation was x is equals to a 4a and y is equals to a 4a. That means the point of intersection was known to me as 4a comma 4a. Yes, and once the integration has to be done, my dear friends, how the integration would be? So far I was telling you can have the single integration taking y1 as a function of x, y2 as a function of x, and end of the day dx, where the x goes from 0 to 4 of a. Rather calculating in terms of single integration, even you could have converted this problem into the double integration. See how this component could have been changed into the form of integration of dy. This could have been written as dy, where the upper limit would be y1 of x, similarly the lower limit would be y2 of x, and this component together fabricates this component. Yes, and end of the day we had to take the integration where the x goes from 0 to 4a d of x. 4a d of x. Agreed what I am saying? So once you will calculate this, definitely you have to follow this complete process. The result what we get is simply gonna be a is equals to of 16a square divided by of 3. The result what we get from here is gonna be 16a square divided by of 3. So in the same sequence, let me take the next question. So the problem comes from the page number 33. Yes. You had to get the exact most answer for this given problem. Let me see, this problem has appeared in which branch? It has been appeared in mechanical engineering in afternoon session. Tell me what would be the best most answer for this given problem. See what this problem states. Again, this problem has been the problem over the concept of double integration, where the double integration has been taken place over the r and theta domain. Yes, dr and d theta are the symbolic representation that the integration has been taken over the r as well as theta domain. So tell me, how will you process this problem? My dear friends, in yesterday's class, I have taken a problem which were based on the triple integration. And once you'll see the limits which were involved in all of the three integral components, they all were constant. And that is why the sequence or the ordering of the integration was not making any sense. But here this is not the case. Once you will visualize the limits of the integral, you will get to know the integral limit has been 0 to cos of theta. What does that mean of it? The cos of theta indicates the cos of theta has been the function of r. Yes. What has been is, so you can say it has been the r1 which is supposed to be the function of theta, and it has been the r2 which is supposed to be function of theta. So one thing has been quite sure, at very beginning the integration has to start. The integration has to be start with the r itself. the integration has to be start with the r itself. Once we are done with r, my dear friends, once we are done with r, so the r would be fed as the function of theta. So once we are done with this integration, only the component of theta would be left out. That means in second, the integration has to be taken place in terms of theta. Could you understand what I am saying? So at least this function indicating a lot that the integration has to be initiated with respect to the r first. Once we are done with the r, we had to initiate further with respect to the theta. Yes. So what I would be doing, whenever you have this sort of problem, at least have fair idea. The integration first has to be taken place in terms of r. Once we are done with this, the integration has to be taken place in terms of theta. In terms of theta. Okay. Keep integration of 0 to pi by 2 aside, just focus over the integration of 0 to cos of theta, and the integration has to be taken place with respect to the r. What does that mean of it? That means in that case, the component of theta or the function of theta would be treated as a constant. So only the integration of r would take place with respect to the d of r. So the factor which is going to come out is simply going to be, we can write over here, it's going to be the integration from 0 to pi by 2. If any of us had any sort of doubt, they are the limits of the theta, because the integration with respect to the theta is going to take place at last. Yes. Now, first the integration has to be taken place with respect to the r, so obviously the sine theta would be coming out. Sine theta would be coming out. Sine theta would be coming out, and here the integration of r would take place with respect to the dr, that would be simply equals to of r square divided by f2, where its upper limit would go to the cos of theta, and similarly its lower limit would go to 0, and here would come d of theta. Here would come d of theta. So till this point, probably each and everything must be clear to all of us. Probably till this point, each and everything must be clear to all of us. Yes, the sequence makes a lot of sense. So anyways, the complete solution is already brought to you. See, that is why the integration had been initiated with r. Once the integration is being made, so the factor of the integration of r has been r square divided by f2. You will be taking its lower as well as upper limit, where the lower limit was 0, the upper limit was cos of theta. Once you will be feeding so the result what we get, it's gonna be I is equals to of half times of integration from 0 to pi by 2 of sine theta of cos square theta of d theta. This problem could have been solved from two different methodologies. Either you could have used the important property which we use in case of beta integration, when we used to have a function of an integration from theta is equals to 0 to pi by 2 sine to the power of 2m minus 1 cos to the power of 2n minus 1. Yes, I could have solved this problem using that method. That could have been the first methodology. What I said. Or secondly, I could have used the conventional method. May I know how it would be? I can take sine of theta as t. What I am saying? I can take sine of theta as t. So once I'll differentiate both other side, so the factor which should be left out is simply going to be, it's going to be cos of theta dt by of d theta, or I can say cos of theta d theta is equals to of dt. No, but this would not suffice my requirement, because I want the cos square theta over here. So rather taking sine of theta as t, why don't we take cos of theta as t? So what I am going to do over here, let me go back. Rather taking sine of theta is equals to t, let me take cos of theta is equals to of t. Yes, cos of theta is equals to t. Once we will take differentiation both other side, the differentiation of cos of theta would lead minus of sine of theta, and similarly differentiation of t would lead dt by of d theta. dt by of d theta. D theta can be shifted towards left hand side, so the factor which should be left out is simply going to be sine of theta d theta is equals to of minus of dt. That means the cos square theta can be fed as a t square. Similarly, sine theta d theta can be fed as a minus of dt. Okay, we'll do the same. What I am saying, the sine theta d theta would be fed as a minus of dt. The minus sign has been brought out, and similarly the cos theta has been t, so cos square theta is going to be t square. Yes. Now one major mistake the people do, whenever there used to be a substitution of the variable, limit would also be affected. See, first the value of theta was 0, so once you will be feeding theta is equals to 0 now. The value of t which would come out It's simply going to be 1. Yes, once you'll feed theta is equals to 0, the cos of 0 would become 1, which is the worth of t, and similarly there could be the second possibility, when the value of theta has been fed as pi by 2, the value of t would become 0. Hence there would be an integration from theta is equals to 0, that means t is equals to 1 to 0, and once you will integrate, so the answer what we get, you can get by yourself, and the answer what we are getting for this problem is simply going to be 0. Not C, the answer what we are getting is going to be 1 upon 6. So probably till this point each and everything must be clear to all of us. So the part of calculus is done in today's class. What we would be doing from here onwards, in the next class, I would be taking the part of numerical methods as well as the part of few interesting questions which have been appeared from the vector calculus. What I am saying? In the next video, we are going to focus over the vector calculus, and similarly, we are going to focus over the part of the numerical method. And probably within 2 to 3 days, we would be done with all of the questions which has been coming in GATE year of 2021. So probably I can interact with you guys. Tell me, how about your preparation going on? So out of 5 number of concurrent viewers, just wanted to ask from each one of you, how many of us have already been appeared in GATE year of 2021, and how many of us are freshly going to attempt in GATE year of 2022, and which are the different topics within the engineering mathematics which you guys find difficult? So you can just post it over the live chat, so at least I'll have the fair idea and I can discuss those topics in future. So just wanted to ask 2 things from you guys. The first thing, whether you are freshly attempting in GATE 2022 or whether you have already attended GATE 2021. That's the first question. Secondly, among the complete topic of the engineering mathematics, which are the topics you find very difficult? Subham Jain, not yet properly prepared, sir. Subham Jindal, just wanted to know, this would be your first attempt in GATE year of 2022 or whether you have been attempted in GATE 2021. That's the first question. Attended 2021, no. Okay. Subham Jindal, then in that case I would request to you, just follow our complete video. This has been the questions which have been appeared in year of 2021. So the student who have not appeared engineering mathematics at all, they would have find bit difficulty during this session, because this session requires a bit amount of understanding of the engineering mathematics. Once we are done with this, we would come with the basic most part of the engineering mathematics, and we would start from 0 onwards. Definitely you are going to like those sessions. Anyways, we would meet tomorrow with the same agenda, where we would be meeting with the next topic of the engineering mathematics. Till then, bye bye, take care.